This is the lesson for chapter 5, section 4, point slope form, day 2. So let's take a look at our types of problems we'll see today. It says write an equation in point slope form for each line. So on this one, they're giving us the equation, or they're giving us a line, and we have to write the equation for it. So what we want to do is we want to, first of all, see what the slope of that line is. So what I'm going to do is I'm going to draw a slope triangle. I'm going to start at the left-hand point and go to the right-hand point. So I'm going to go down and count the spaces down and then across. And they also are giving us the ordered pairs, so we could end up using those and find the slope. So I'll do that method on another problem, but for right now I'm going to use the slope triangle for this one. So I count the spaces, 1, 2, 3, 4, 5, 6 spaces down. So down 6. Down 6 means negative 6. And then I have to go 1, 2, 3 spaces right. Positive 3 means that I went right 3 spaces. So my slope of this line is negative 6 to 3. And so that would represent negative 2 as the slope. So now I want to find out what this equation is, because I don't see the y-intercept. It's not really visible to me. I don't see where it crosses. So I can't just write the equation. So I need to use a point. And so I'm going to use this point right here. I could use either point. Doesn't matter which point you pick. So either point will give us the same equation. And it should, because we're trying to write an equation for this line, and both points are on the line. So no matter which point you pick, it's going to end up working. So I'm going to use the point slope method. Y minus y1 equals m times x minus x1. So I'm substituting my point, and I'm going to pick this point again. So y minus 3 equals the slope, which is negative 2, times by x minus negative 4. So again, that minus negative makes a plus positive, and I distribute. So now I have y minus 3 equals negative 2x minus 8. So again, prior to me distributing, this was point slope right here. So right here was the point slope form. And so if I wanted to carry it on, though, I would have to distribute, and I'll just continue on from here. I would add 3 to all sides, and I'd get y equals negative 2x minus 5. So that tells me at negative 5, that's where that graph is going to cross that y-axis. And this is called slope-intercept. Slope-intercept form. And this is the one that's really critical to understand, because it gives us the rate of change and it gives us where it crosses the y-axis, so it's easy to picture where that graph is. So we'll do the same sort of thing for this one. Notice how this one, we're starting at the left, working our way to the right again. This time we're going up a number of spaces and then over to the right. So up 1, 2, 3, 4, 5, 6. So we went up 6 spaces. That's a positive 6 because we went up, and then we went right 2. So that's positive 2 because, again, we went right. And so from there, we can go ahead and write out our slope. Our slope is going to end up being up 6, right 2, so that makes positive 3. And so again, either point works. I'll pick this point this time. And so I'll use my point slope formula. Y minus y1 equals m times x minus x1. And I substitute the point into the equation. Y minus negative 3 equals the slope, which we said was 3, times by x minus 1. So well, if I go ahead and just add the opposite, this would be the point slope form that they're looking for, if they're asking for that. So this is point slope. And if we carried this out further, we would distribute that 3 over the x minus 1, and that would give us 3x minus 3. So then all I'd have to do is add the 3, and you'll notice that, well, actually I shouldn't be adding, I should be subtracting. So let's fix that real quick. Opposite operations will solve the equation, so I have to subtract the 3. Y is going to equal 3x minus 6. Same sign, so I add. And this is slope-intercept. Intercept form. So let's take a look at the last one. I think we'll go ahead and just use the same method. Next time we'll end up having to use the slope formula on the next problem, so might as well stick with this method for now. So it looks like if you look at this is halfway up. We've got to be careful there. It's not right on that point. So this represents a half space and then 2. So that's down 2.5 spaces. And this is over 1, 2, 3, 4, 5 full spaces to the right. So it's positive 5. So we went down 2.5, right 5. And so when we go ahead and take a look at the slope equals, and then I'm going to change this to an improper fraction. So negative 5 halves over 5. So watch what happens when I do this. So this fraction bar is like a division sign. And I can rewrite the problem this way. And so then you'll notice that when we do have that division, that means multiply. So I'm going to change that to multiplication, and I got to take the reciprocal. So whenever you have a fraction over a fraction, pretty much what you're doing is you're multiplying the denominator by this denominator. So you can see how that makes negative 5/10, which makes negative 1/2. And that's going to be a simplified slope there. So that's the slope I'm going to use, and I'll use a point. So we're going to set up the problem into point slopes. So y minus y1 equals m times x minus x1. And now I'm left with y minus, and I'm going to pick this point right here this time, y minus 9 equals the slope of negative 1/2 times by x minus negative 4. So again, that minus negative makes a plus positive, and that's our point slope form. That's point slope. And so if I continued this problem, I would be solving for slope-intercept form. So negative 1/2 x minus, because the negative times a positive, minus 2. Half of 4 is 2. So from there I just add the 9, and it gives me my equation. Y equals negative 1/2 x plus 7. And that is slope-intercept. So next problem is going to be one in which we have this table, and it says that the model of the data in each table, model each data in each table with a linear equation in slope-intercept form. What do the slope and the y-intercept represent? So first thing we need to do is figure out what is our x, what is our y. Remember, x's represent the independent variable. And so that's a number that you can put anything in for, where y represents the dependent variable. And so when you think of independent, these are inputs, and the dependent are outputs, what you get out from something. So time of washing, and then cars washed. Cars washed is dependent. So dependent on the time. So this is independent. And that helps us figure out which is our x and which is our y. This is going to be our x, this is y. That's important when we're trying to find the slope, and that's what I need to do. So all you're going to do is just take 2 of the points. And it doesn't matter which 2. I'm going to pick this one and this one. I did that because look at the x's. They're only 1 apart. So I'm going to do 36 minus 30 over 6 minus 5. The critical thing when you're doing slope, using that m, and I'll write that formula down again, the change of y over change of x. So the critical thing about change of y, it's y minus y1 over x minus x1. You've got to get the same points in the same location. So like I pulled from the 36 right here, minus 30. So then I have to start with 6 minus 5. Otherwise you're going to get a sign error. So that makes 6 over 1, which just makes 6. So what that represents is we had hours in the bottom, cars washed on top. 6 cars per hour is what that represents. And so that's what we see. Now we're going to try to write an equation. So y minus y1 equals m times x minus x1. This way we can predict how many cars we'll have washed later on. So I've got y minus, and then I'll take a point. Doesn't matter which point. Pick any point. I'm going to pick this first one right here. And so I've got y minus 18 equals the slope of 6 times by x minus 3. So I distribute. I got y minus 18 equals 6x minus 18. And look what happens here. The x's end up, or the constants end up canceling out. So when you have the same term on both sides, when you do that opposite operation, they're going to end up canceling. So y equals 6x is the solution. So what does this mean? Well, it means that we'll have the slope again was 6 cars per hour, and that's what they wanted us to represent. So what do the slope and y-intercept represent? So the slope again, the slope was represented 6 cars washed each hour per hour, and the y-intercept means that we started with zero cars. There were no cars already washed, and that's what that represented. So let's take a look at the next one. Time flying, distance from airport. Time is typically going to be our independent variable, and it is. That time is, or that distance from the airport is dependent on time. So this is independent, and this is dependent. And so we'll go ahead and call this our x, this our y, and we'll set up our equation. So we've got to pick some points, and I'm going to just pick the first 2 points here to find out what my slope of the line will be. So I'm going to start with this point right here, 3,600 minus 2,700, and I subtract. Now since I start with the 36, I got to start with the 2, so 2 minus 4. And so I do the subtraction. It looks like it's going to be 900 and then over negative 2. So when we go ahead and do that reducing, that gives us a negative slope. And so what does it mean? Well, if you look at the units, it'll tell you. The top of the fraction, again, I could write that as over 1. Top of the fraction tells me miles. And then this bottom of the fraction tells me hours. So that tells me that I'm going 450 miles away from the airport every hour. So that's 450 miles away from the airport each hour. And so that's what I'm doing there. That's what that slope represents. So that's what that is. Now let's find the equation. So y minus y1 equals m times x minus x1. So I go ahead and substitute. Take any point. I'll just pick this first point right here, and I'll substitute in. I got y minus 3,600 equals the slope of negative 450 times by x minus 2. So when I go ahead and distribute, I've got now y minus 3,600 equals negative 450x plus 900. And so I got that 900 by multiplying negative 450 by negative 2. So when I go ahead and add this 3,600 to both sides, add that 3,600, this is what I get. Y equals negative 450x plus, and I get 4,500. So what's that y-intercept represent? We would know the slope. The slope was 450 miles away from the airport each hour. Well, the 4,500, this number right here, that number represents, that means we started this many, 4,500 miles from our destination. So we started 4,500 miles from the airport in this case here. So I'm going to get rid of that, from the airport. And let's fix this top portion here. 450 miles not away from the airport. Since it's negative, we're actually going to the airport. So as you can see, distance from the airport is getting closer and closer. So 450 miles away from the airport each hour. Well, actually, we're going 450 miles closer. So let's go ahead and change that right now. So we're going 450 miles closer to the airport each hour. Because as I was looking at it, it looks as though we're getting a little closer. So after 8 hours, we're only 900 miles away from the airport. So let's take a look at our last type of problem here. And this one says, a sign says that 3 tickets cost $22.50. 7 tickets cost $52.50. Write an equation to solve. So when we're talking about this, we've got tickets and we've got dollars. And so the tickets are going to end up representing our independent variable, where dollars are dependent on the number of tickets we buy. So I'm going to set it up this way: tickets, comma, dollars. And that's going to be my ordered pair. So I've got 3, comma, 22.50, and then I've also got 7, comma, 52.50. And so I'm going to go ahead and set up my slope formula, which is y minus y1 over x minus x1. So I substitute in, I've got 52.50 minus 22.50. And then down below, I'll end up doing 7 minus 3. So when I go ahead and do some of that work, it looks like I'm going to end up with a negative 30, or actually positive 30, since I've got more positives than negatives, over 4, which reduces down to 7.5. And so when I go ahead and take a look at that, again, the C represents, I'm going to say C equals my cost. And so that's going to be my Y component, and we'll say T represents tickets. T equals number of tickets. And so we go ahead and set up the formula this way: C minus 22.50, so I'm just taking one of the points here, I'm taking this one right here, equals M, which is 7.5, so let me go ahead and substitute that in there now. 7.5 multiplied by the T minus 3. So when I go ahead and do some work, C minus 22.50 equals 7.5 minus 22.50. And so when I go ahead and add that 22.50 to both sides, it cancels it out. So I'm left with C equals, and I've got to get the T in there, equals $7.50 per ticket. And that would be my equation. So those are the types of problems you're going to see on tonight's homework. Good luck.